Hi folks, this is Tom Affolter. Welcome back to my SQL class. Today I'm going to introduce you to some new material. We're going to start off with a couple of new SQL statements. I'm going to dive in and talk a little bit about spin-off tables, and then we're going to close out by talking about views and the advantage of the views. So let's go ahead and get started here. Let's first take a look at the between statement. So far, when we were writing out our select statements within our where clauses, we were writing it out in complete logic. An example that we have on a slide here, where price is greater than or equal to 50 and price is less than or equal to 100. And that basic logic grabbed out everything between 50 and 100 inclusive. So now let me show you, we have a new command that's going to shorten things down a little bit. We can use the between statement. If you take a look at this bottom example, it says select all records from orders where the price is between 50 and 100. Basically the same statement that we have above. The only difference you need to understand is I don't have to do a greater than or equal to because the between is inclusive, which means it's also going to include 50 and 100. I can also use the not statement with that by going back in this bottom example and asking it, I want everybody but those between 50 and 100. Let's take a look at an example of this one. So I'm going to go ahead, I'm already logged in, let's go into baseball. Right here, there's my tables. And just to make this simple, we've got the weight that exists, and what I'd like to do is I'd like to get the players that have a particular weight. So let me go ahead and do a new query. And I will do select all columns from players where, oh, my enter key still is not working right there, where. And if I was looking for weight the old-fashioned way, I could say something like I might do something like where weight is greater than 100. We're going to get the lightweight players here, and weight is less than 200. Now these are exclusive, which means I'm not going to get players that weigh 100, I'm not going to get players that weigh 200, but anything greater than 100 and anything less than 100, or excuse me, 200 I should get. And if we came over here and we took a look at the weights, we're going to see that it brought 13,000 different players back, and all those weights should be in between. Now if I wanted to, I could do a greater than or equal to, less than or equal to, and now it's going to be inclusive. Now if you look down the list here, there's a 200 weight there that we wouldn't have got in the previous example. Now let's convert this into the between clause. So I'm going to go ahead and copy that. I'll leave them both on the screen for comparison, and I'm simply going to say select star from players where weight between, and I just give the starting and the ending here. So I want where the weight is between 100 and 200. And now if I run that, I should get the same data that I have down below here. Okay, and I do. There's my weight right here. Now, if I wanted everybody else, I wanted everybody that wasn't between, I could then say where weight and put a not statement in front of this. That inverts it. And now I will get everybody but those people that are 100 to 200 pounds in weight, as you see over here. So between does shorten down your code quite a bit. I'm an old dog, so I still tend to do it this way. Let me increase that font a little bit. I tend to do it this first way, but either way they work. And again, that's my ultimate goal for you folks is, does it work? Does it give back the data that it's intended to? And whether you choose one or the other, unless I specifically tell you to use the between statement in practice, I don't care which one of these statements that you use. This is an ANSI SQL statement, by the way, so you'll find that this statement exists in Oracle. It exists the same way in MySQL across the board. Now we can also use the between statement, I should mention, in dates too. So let's go back and take a look how we might use between in dates. So far I've got where weight is between. Let me get rid of this top one here, and let's change this a little bit. Let's say we want all the people that were born between January 1st, 1960 and December 31st, 1969. So I could say, we've got birth date over here. So I could say birth date, and let's take the not out. And I want it to be between, remember we put these in apostrophes, so I want it between 1960, first day of that particular decade, and let's see, December 31st, 1969. Okay, let's double check it, make sure the format's correct. It is, and let's take a look at what we end up with. So now we should find out we only have players born in the 1960s over here within our birthday list. So again, very, very powerful. If it makes sense to you, go ahead and use this version of it. I know a lot of students like it. The challenge I have with the between statement is just the concept of logic. I'm used to the old days of where you put an and statement in there, and that end meant something different than this. I should point out that in this statement, the between and the and statement are closely related, meaning that the between statement and the and statement expects to find that between statement. If it doesn't find between before it, it thinks it's a general or a standard and it's going to look for complete logic on both sides. Let's take a look at the in statement. In statement's a very, very interesting one because you can do some really powerful stuff with it. It again allows you to simplify your logic. So in the past, if I wanted to get all my orders that were from either the state of Washington, the state of Oregon, or the state of Idaho, I have to use complete logic. And this is similar to what the previous problem was. So I'm going to say where state is equal to Washington, or the state is equal to Oregon, or the state is equal to Idaho. Now we have an in statement, which is again an ANSI SQL statement that lets me shorten that down. Other languages have what's called a set statement, which is very similar to this. What it does is it just basically says within a where clause where state is in this list, and it does exactly the same thing. It basically ORs those together. So in this case, I'm saying where the state is either Oregon, Idaho, or Washington, and these two statements above are going to be pretty much identical. And if I want those people again that everybody else, but I do not want Oregon, Idaho, and Washington, then right before that in, I'm just going to put a not statement in here. Let's go back and take a look at this example. So we had the between statement before. Now what I'd like to do is I just want those players, just like we were looking at before, that were born in certain states. So I'm going to say where, and let's double check on that, birth state. Okay, going back to that format where birth state is in, and then I'm in parentheses, I'm going to include that data. So I'm going to come back and say I only want, let's say I want Idaho, I want Washington, and I want Oregon. Okay. Now, writing this out the long way would have been where birth state equals Idaho, or birth state equals Washington, or birth state equals Oregon. But this is a shortcut version of it here. So let's go ahead and check this, make sure it works. It does, and execute it. And now you'll see within the birth states, I only have those three right here. And of course, I could put a not in front of this, which inverts it. And now when I run it, I will get every state except Idaho, Washington, and Oregon. So it's a pretty easy statement. It's really nice when you have a big, giant OR clause that you're putting in there. It shortens it down dramatically. And this is one of the few statements, because I am a very big advocate of less typing, that I will use often. Now, let's take a look at what we can also do. We've looked earlier at some of the power use inside of the select statement, how we can use a select in a select. And the in statement is very similar to that. So let's say that I came back over here and I wanted to write a select statement, and I only want to have states brought up where, oh, I'm not sure how I'd want to even do this one right off the top here. Let me look this over again and see what I can come up with. Okay, so let's write a select statement from players, and I want the states where the original baseball players were from. So I want to know all the states, select all the states. Let's see here, we'll do that. So we'll do birth states from players where, and let's find those players that died before 1900. So let's do death. Oops, where, let's correct that here. Where death, date of death, is less than, and I'm going to write it all the way out here, 1900. Let's make sure this guy works here. And is that correctly? It's death date. Check it. Does it work? Okay. Now, what I've done is I've gotten a list of all those states that players played in. What I'd really like to do is just have these listed once, because you're going to see there's a big repetition in here. So let's just get the distinct states. What I'm basically doing is I'm saying, show me those states that players were born in that played baseball prior to 1900. Not sure how significant this is going to be, but I only want them listed once. Distinct. Okay. And just for the heck of it, let's order by birth date. Okay, so when I run this, these are all the states, including a null, and let's exclude nulls, where the death date is less than and birth date is not null. So we can get rid of that guy, because I just want a list of the states. And null is one of those entries. Oh, and birth rate is not null. Okay, so now I've got a list of all those states. I see that I don't have, I have Alabama, but I don't have Arizona. I don't have Alaska listed in here. These are the only states that in that time, and there's probably going to be some Canadian in here as well. But these are the states. Now what I want is, if we go back to this example again that I've used here, I only want those records that currently exist from those states. Okay, so let's go back in and take a look at how I would have otherwise done it. I could have gotten this list back just like this, and then gone back in and wrote individual statements, or put or statements and said or Alabama, or where birth state equals Alabama, or birth state equals California, or birth state equals Connecticut, etc., etc. That would have been massive. So what I really can do here is I'm going to come back and write a statement here. I want all records brought in from, and I'm going to use this same concept right here. So I'm going to say it from players where birth state is in, and again, right here in this list, if I even wanted to take, shorten it down from the N's and O's, I could have gone back in this list and done this basically. I could have said, okay, AL, comma, CA. Where am I getting those from? I'm getting those, it should be capital A. I'm getting that from this list down below here. I don't want to do that. But what I can do, folks, is I can take these parentheses right here, and as long as this select statement right here returns only one state, that state will be built within this list. So check this out. Let me take those out, and I'm going to grab this entire select statement right here. I'm going to cut it, and I'm going to paste it right here, right in the middle. Okay. So now it's going to run the select statement first. It's going to come up with a list, and then it's going to select players with birth states in that list. So this list only gives me those players that were born before 1900. So what I'm really asking for here, it's kind of crazy, but I guess I'm asking for all the players today that play baseball in states that had baseball players prior to 1900. And this is what I'm going to end up with. Uh-oh. And I cannot have an order by clause in this embedded statement here. So always read those messages here. I did that to look at it before, but I don't need an order by in that embedded. So let's see if that's going to take a work here. There we go. And there we're going to find that we won't have any Alaska listed in here. We won't have any Arizona because they were not in this original list that we had up here. So again, another really cool power user tip here that you should take advantage of and understand and learn. Now let's take a look at a power user case statement. This is the only statement that I'm going to talk to you about that is a Transact SQL statement. That's not an ANSI SQL statement. Pardon me. And the reason that I bring this up is because it's such a valuable command, and it does exist in all the other versions in a little bit different formats. So IBM's DB2 has a version of the case in it. Oracle has a case statement in it. You're going to find case statements exist in those extended SQLs out there, and I want to spend just a moment and talk to you about it because, again, it is so cool on what it does in here. So the basic idea is the case statement will replace a column, and what it does is it looks at a condition of that particular column, and what you can do is you can say, if this column has this value in it, then print this in the column. Otherwise, print this, and we can daisy chain these together and say, you know, when this is equal to this, then put this value in. Else, when this equals this, then put this value in. And what it allows us to do is it allows us to encode our data, if you will, or it allows us to go back in and print out what that data might otherwise be. So an example of that might be if I have type membership, and I've decided to encode my type membership because I don't want to store lifetime member or annual member or guest in there. I'd like to just store a 1, 2, or a 3 in there. But when I print that out in a select statement, nobody has a clue what 1, 2, or 3 is. So as the select statement generates, I'd like it to convert number 1 perhaps into lifetime member, number 2 perhaps into the annual member, and maybe number 3 into that guest member, if you will. And that's what the case statement does. But that again is only the tip of the iceberg on what it'll do. This is one of the most powerful statements as far as I'm concerned that exists in a SQL world. So let's take a look at an example about that membership that I had a minute ago. In the very first example here that I have, let's assume that we have this bit field out there. Remember, a bit field is true or false. It either holds a 1 if it's true or a 0 if it's false. So what we did is let's assume that we've created this membership table out there, and as people are put in, as names are put in this table, we want to ascertain if they're currently a member or not. Maybe their membership is expired. So if they are a member, there's going to be a 1 put in that field. But if they're just applying perhaps, or if their membership is expired, they're going to have a 0 in it. And when we write our select statement out, I don't want it to print out a 1 or a 0. What I want it to print out is a member or not member. And that's exactly what this case statement's going to do in this instance. So you start off with the keyword case and then when. And there's a couple of different versions of the case statement, but this is the one that I like the best. So you say case when is member, so that's a column in this table. If is member is equal to 1, then you put in that column the text member. Otherwise, because it's a Boolean setting and you know if it's not a 1, it has to be a 0, you use this else statement over here and say otherwise, say it's not a member. Now, if there was more than one option, then we could then say when member is equal to 1, then member else member equals 2, then blah, else when member equals 3, whatever. We can daisy chain these together as we're going to see here in a second. But this is extremely powerful. Here's an example, another example of how you might use it. And in this case, we're going to use it to determine logic. What we're trying to do is if the donor in our donation table donated less than, so notice I've got this math formula here, or this comparison. Case when the donation amount is less than 100, put on the screen that they made a minimal donation, or at least in that respective column. When the donation amount, so this is where they're daisy chained, when the donation amount is less than 1,000, then put in a median donation. Otherwise, default it to a large donation, because these should have caught it before, which means that their donation has to be greater than 1,000. So default to large. Now notice that when you have a case when statement, you will always stop it with an end statement. That tells it the case is over. So case when, you've got your logic, and then you have your end statement. And this is going to be considered a derived column. So you'll always have to give it a column header at the end. So notice here's the output that I would get from our table. Notice I have the donation amounts in here, and over here on the right hand side it just has the word large, medium in here. So we don't have anybody on this particular slide that did do we have a minimal in here? Nope, we don't have a minimal donation. So nothing in here that's less than $100, but that's what that would have caught. So let's go back in and take a look at something like this in operation. Okay, so we've got, what I'd like to do is from these players, I want to do just basically what we did before. I want to take a look at their physical structure and come up with some definitions for their physical structure. What I might want to do is go back in and say, okay, if they're between a certain weight, they have a small structure. If they're between this weight and this weight, they have a medium structure. Otherwise, we're going to consider them having a large structure. So let's go ahead and figure out how we're going to do this. So I'm going to go ahead and take this guy, all this logic out right here, and we're going to come back in here and let's simply add in, to simplify this, we're going to use a name last, name first, and then for right now I want to put weight in. And then what I will like, and I'm going to put this in a separate line down here, now I want to put a case statement in that's going to analyze this weight. So I want it to display the weight, so if I run this right now, I'm just going to get those 3 columns with weight included over here. Now, I want the weight to be analyzed, so I'm going to put a new column in here. So to put a new column, I got to put a comma here to tell it there's a new column coming on, and now I'm going to start it off with my case statement. I'm going to say case when, and let's just determine that if somebody weighs less than 150 pounds, they're light. So I'm going to say when weight is less than 150 pounds, then what I want to do is I'm simply going to put the word in light. Just like that. Now I'm going to break it apart. I could put all this in one line, but I'm going to do the next line down, and I'm simply going to say when weight is now less than, and let's put down, let's assume if it's less than 200, then we're going to call them medium build. And let's do another one. Let's say when weight is less than 250 pounds, then large, and anybody over 250 pounds, else we're going to come in here and say otherwise. I'm just going to assume anybody that doesn't fall in one of those 3 categories, they will fall into this weight, and we're going to say that they're huge right here. Now, in order to make this work, I have to close out the case. I'll use an end statement here, but then I have to give it a column header. So I'm just going to call my column header build, and I could write that out again depending on the shortcuts we're going to take as build, just like that. So I got that extra line in here. Let's check this and see what happens. It says it worked okay, so let's come back and run it. And you'll see, looking down the line here, here's a 220 weight for David Artsema. So 220 happens to be large. It happens to be less than 250, but it's greater than 200. And what you'll find out is that once one of these rules is hit, unlike languages like C#, language says that once you hit this language, you have to have what's called a break statement in here that says, okay, you found this one, you've set it at light, break it, and jump past the end. You don't have to do that within SQL. SQL says if I find that this is a true statement, I'm just going to run that one statement, and I'm done with it, I'm going to jump to the end. So that's what's happening here. That's why we put it in the order we did here. If we had done this backwards, it wouldn't have worked. Had I put large first, everybody would have been less than large, so it would have always caught it here. So I started the smallest to the larger down here. Okay. So hopefully this part makes sense. You see how it worked out? Let's jump back and take a look at some more. Here's an example where it has a AND statement built in. So not only can we put a single statement in here, boom, 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 we can also put an AND statement in here. So I could say something like, boy, I'm not sure how I could fit height in here, but I could say, okay, and height is less than whatever, 6 feet 70 inches, something like that. So I could combine logic in between the where statement. It doesn't have to be just a single statement. It can be complete logic, and it can look at different columns within that same table. So folks, this is an extremely powerful. Let's take a look at one other example before I leave. You'll notice that under bats, when we list out bats, so let me do a select star here. Let's just run that statement. That right now, bats comes out as either an R or an L, or if we were to look a little bit deeper, we're going to find that there's B's in there for both. Okay. Maybe my people looking at this don't know what an R, L, or a B is, because that's just simply an abbreviation. So what I'd like to do is, for my output, I would like it to come back in and print out left, right, or both. So let's take a look at how we might otherwise do that one. So I'm going to come back in and modify this statement here, and I want it to come back and put in bats. So I want it to show what the bats is. We can delete this column later just to show what it's going to look like. And then I'm going to say here in this statement, when bats equal an L, then I want to put in left. Okay. When bats equal R, okay, I wanted to put in right. Now, I've got an interesting quandary here that we should talk about, and that is that there are going to be some nulls down in this throws column. There's going to be, in the bats column. Early players maybe that they just didn't record. That's a potential. So what I would like to do here is I'm going to go ahead and complete the logic out. I'm going to still test for both when bats. Normally, if I knew it was only going to be L, R, or B, I would just come back in here and put an else statement and say if it's not L or R, it has to be B. But there are nulls in there. There's a potential for nulls. So what would happen is if I do L or R, anything else, whether it's both or null, it's going to replace it with a both if I left it that way. So I have to address both of those situations. So I'm going to say bats, and look at that. I said less than R. That better be an equal to. I heard somebody grumble out there. Okay, here I'm going to put both. So if it equals both, then both. Actually, we call that switch hitting, so let's call it switch. There's switch hitter. That's the term with one T. Else, now I know the only thing that's going to be left over is going to be anything that's not left, right, or both, which has to be, in this case, null. I can test for null, but I don't need to test for null because I know that that's all that's going to be left over. So what I'm going to do here is I'm simply going to change this statement, get rid of this guy here, and use that bottom one. I'm simply going to say else unknown. I'm going to say unknown. Now let's just let's use it as UNK right here. Case switch else. Did I make a mistake here? Oh, my then end. There we go. Okay, and then let's leave that as new bats just for now, just to prove it's going to work. Okay, let's execute the statement, and now you'll see that it's now replaced all those statements down below with left or right. We don't have a lot of switch hitters in there. Let's just thumb down here really. Oh, there's one right there. I saw it. Switch hitter right there. There's a switch hitter. I don't know if we have any unknowns in there, but you notice now my data is accurate. Now, once I've got it tested, and proven, I'm going to take bats out right here, get rid of that. I don't need this any longer because it's been converted across. Get rid of that, and I'm just going to call it bats now. And now when I execute it, I just have the correct data. Again, folks, extremely, extremely powerful. I suggest you spend some time and you play with it, and go back out and research out that case statement, because there are a couple of other variations on how you can use it. I think this is the most universal way to do it. That's why I teach that version of it. Ooh. Now let's take a look at another really, really cool statement that you as a programmer will probably use a lot, or want one of your database people to set up for you if you can't do it yourself. So sometimes you want to do a wildcard search. You might come back and say, give me all the names that start with SM, for example, where you'd get the Smiths and the Smyths out there, or the Smolts. Or you might want to provide a list of all the cities that end in the word falls. Or you might want to find all the cities that have just simply KANE anywhere within that city field. Now, why would you want to do that? Well, maybe you're trying to search for a particular term and the user doesn't remember exactly how to word it, but they can get partial spelling on it. Or maybe what you're doing is you're going back in and creating a text box that has a search feature in it. So as you type in the A in that text box, it returns back in some kind of a table on the form every name that starts with the letter A. And then when you put the D in, it says, oh, we'll switch it to everybody that starts with AD, or you put ADA in. And that's how you would write a search feature in a database. But the challenge is you're not just looking for ADA only within that column, you're looking for ADA at the start of the column in this particular case. And the like statement is exceptional. It's one of them that I love, I use often. And let's imagine now that we've got this table, and we're going to come and play with this, and all I want to do is pull out all people, or all customers in this case, who have the last name to start with the letter A. Now, what I've got is I've got this wildcard statement. And first of all, I'm going to use the like statement instead of equal. And by the way, this is where a lot of students make mistake. They're going to confuse the equal and the like. The equal says it has to match this exactly. Whereas the like statement says, nah, it just has to fit this template somehow. And what you're looking at right now, probably the most common wildcard that you're going to use is this percent symbol here. And what the percent symbol says is if it's at the end, so notice the way it sets here is I've got it apostrophe A percent. This says give me everybody who starts with the letter A. If I did an AD here, it would say give me everybody that starts with AD. The percent symbol says I don't care what follows it. But the percent is much more powerful than that. I can actually put the percent symbol as this example on the bottom here at the very beginning. And what I'm saying at the beginning is I want every city that has ANE at the end of the city name. And this bottom example shows a combination of the two, where I've got the percent symbol at the beginning and I've got the percent symbol at the end. This guy says I want the cities returned that any place within that city name has the word city in it. So, and it could be at the beginning, it could be at the end. The wildcard doesn't say it has to be filled in, it just says city has to be anywhere in it. For example, this guy right here would pull out ANE. If all there was a city named ANE, this would pull it out as well. No different than if there was a customer name that just started with just the letter A only, this one would pull that out. So very, very powerful. Let's go back and take a look at this. I like showing this one off. Okay. So first thing is I've got all this information here. Let's pull this out. And what I want to do is I want all players that have a last name. So let's do here, I want all the players where name last is like. And the first thing let's do is let's pull everybody else out that starts with the letter A. So I'm going to start off with just an A alone here. And I'm going to put a percent symbol at the end of it. Okay, just like that. Do I have a mistake in here? Oh, yes, I left a comma up here. Should take care of the error. Let's put a where statement in here. That would make things a little bit nicer. So where last name, not an equal sign, but last name like. Okay, let's check this. It says it worked. Now watch this. Boom. Now it's not sorted them, but it showed me well, it happens to be sorted because the names are in sequence right now, because that's how they were entered by the original, what's the guy, Lehman, when he put them in. He put them in alphabetical sequence. That was the primary key order. But nonetheless, you'll notice that the only names that I have in here, if I go down the list, are names that start with the letter A. Okay. And if I came in and said, oh, I want the names that have the letter C after it, and I execute it, now I have only the names that have the letter C in it. But if I was to change this around a little bit, let's find ACK, okay, just like that. So that's only going to give me the ACKs. But if I put a percent symbol in front of this and took this one at the end out, now what's going to happen is it's going to give me every name that ends in ACK. Let's see what we've got out there. Notice Black, Kamak, Clack. Every one of these ends in an ACK. Or, if I want, I can find everything, everything where there's an ACK anywhere within the name. And let's look down. So there's an ACK at the beginning, ACK at the beginning. There's an ACK right there on this name, right in the very middle of it. There's one in the middle. ACK is at the end. So you'll see, as long as that exists anywhere, let's find out how many names have a letter X anywhere in the name, just the letter X. And you're going to see there's Alexanders, Baxters, Coxes. How about only those that have the X? Do we have anybody who has an X at the end of their name, like Alex, Cox? Or only that start with the letter X. Nobody in our table has a name that starts with the letter X, but I'm sure there's many who start with the letter Y. Extremely powerful, folks. Where I love this is when I give my users the search ability. So if they're looking for a name like, say they want to have the ability to type in a name, they will type in into a text box a letter, and I will pass that information in the text box back to my select statement right there. So if they were to type in A to begin with, this is what they would pass to me, and I would run this statement. And then if they passed in D right after that, so they type in AD, and then if they type in an A after that, and you'll see what's happening is we start narrowing in on names. And this may be a drop down, or maybe a list that's in a grid, and as they narrow in, only the names that they want start appearing within that grid. Let's take a look at some of the other operators that we can use. So the most common operator you're going to use in a like statement will be that percent symbol. But occasionally you're going to want to use a couple of these others. For me, about 95% of the time I'm going to use a percent symbol. But if I want to find only a single character, so whereas the percent symbol says I don't care how many number of characters are that match it, if I use an underscore, it says I don't care what that character is as long as it matches my list. So over here in this example, you'll see that it's going to find every name that is only 4 characters long that end in an EAN. Had I put a percent symbol in there, it would have found, didn't matter what the length is, every name that ended in EAN, no matter whether it was 4 characters or more. This says it has to be 4 characters because it's replacing only 1 character. This guy down below says, let's find a range of characters. So in this case, it says, I want all the names from C to P that have arson after it. So it would do Carson, Darson, all the way up to Parson, and it would pull all those names out. So it's a single character replacement, but it works through that complete range. And this one is one that I've never used before, but what it does is it says that any single character not within that specified range. So really what it's doing is it's inverting this guy, and it's saying I want everybody that does not have an L right here within their name. So DE, and give me everybody but no L. It's a powerful one. I'm sure maybe at some point in my career I might have a need for it. There's probably other ways to do the same thing, but I would think, again, if I use the percent symbol most, probably the underscore would be the second one I use. Now let's talk real briefly about alias table names. And right now we know how to go back in and put an alias in a column. We played with that. We've seen a variety of different methodologies on how to do that. And I don't care which one you use as long as it works. So here in this top example, I'm coming back in here. I'm giving an alias to my name column. And I'm calling that, my last name, a comma, and a first name. And I'm calling that my full name. So I'm renaming, or at least I'm giving an alias name to that column that my receiving program will see as full name. I can do exactly the same thing in my table name if I want to. Now, it may not seem valuable right now, but in a moment it might seem a little bit more valuable, and certainly in a couple of weeks it will seem valuable. So in this case, I'm not giving an alias to the name of the table. I'm giving the name of the column. I'm actually taking this membership table name and I'm referring to it as T right here. Now, to be honest with you, in this statement, it has absolutely no use to me right now because the table name is not returned to me. It's the data that's returned to me. But where it's of value is in this. Now, I don't want you to get blown away by what we're looking at on the screen here. But here, surely, we're going to be learning how to do joins. And we're going to join two tables together in order to create output for one table. Now, the purpose of this is not to talk to you how to join a table, but I am here to show you that when you join tables together and you get output, you need to tell it the table name and the column that came from it. So in this case, it's telling me the player ID came from master, name first came from master, but down below here it's telling me that the STINT came from batting, the G came from batting, the AB came from batting, and that's a lot of typing out to do. So what I can do is when I create this, I can go back in my statement, and you'll notice down here, right here, you'll notice that the name of the table right here is master, and I'm joining it with batting. If at this point I don't want to have to type all this stuff out here, I can rename master and batting. The only reason I would want to do it is just to simplify this statement alone. And by me coming back in there and taking and saying, from master as M perhaps, join batting as B, it allows me now to go back up into this table that's up above here and replace master with M. And I end up with what used to be this complicated statement on the top. I end up with what we see down here on the bottom, and it's a little bit easier to look at and it's a little bit easier to type out. I'm not going to go in right now and show you an example of that. Later we'll go back in and do it when we start doing joins, but right now understand that we can apply an alias to a table name should we desire. And you don't have to do that, by the way. If you want to spell it out, you can do that. Now let's talk briefly about what's referred to as a spinoff table. There's several reasons why I use spinoff tables. Probably the most common reason I use a spinoff table is when I'm modifying a table, I don't want to risk losing data. So if I'm going to delete records out, I'm going to insert records, or I'm going to update records, and I'm going to do it to a large number, maybe just to protect myself so I don't screw something up, I want to make a copy of that table just in case I mess things up. So when I make a spin-off table, I'm making a mirror image copy of that table to another table name. But I don't have to do it for the entire table. I can just do it for a piece of the table. And there's a couple of reasons I might want to do that. And we're going to talk about this with views as well. Let's say a particular department comes to me and they say, Tom, I want to have access to a member table, or I want to have access to, here's a good example. I've seen this before. The marketing department comes in and tells the sales department, I want to have access, or not the sales department, let me even back up further. They go back in to the human resources department and they say, we want to have access to some HR data, some name data. Well, it just so happens that some of the HR data is sensitive. I cannot let, as a database person, I have a responsibility to make sure that some people don't jeopardize the privacy of employees. So if the marketing department came to me and says, I want to play around with your data, I want to be able to manipulate it, I want to be able to do some of my own work on it, the last thing I'm going to let them do is have access to my data. So what I'll probably do is make a mirror image copy of that data, or maybe they even want a subset. Maybe they come to me and say, we only want to analyze Washington records. So what I do is I take my entire table, I write a select statement, and I put the output, I redirect the output rather than to the screen to a file, and what I give them is only what they can see and play with. I'm not jeopardizing the original data, I'm letting them have access to it. But it's important to note that it's a snapshot of the data at the moment that I created that spin-off table. What does that mean? Well, that means then that if that department comes to me and asks me for that spin-off table, and I give them their spin-off table, and then I go back in and the original table, I start adding data, it has no impact on that spin-off table. That spin-off table is a capture of the moment that that data was created. When the original table is updated, it has no impact on that spin-off table. Let's take a look at how that is created. So right here, first of all, let's just do it the simplest way. Let's say that I'm going to come back in here now, and I know that I'm going to start messing around with the structure of players. Maybe they've come back in and said, we need to add a new column, or we'd like to have a column changed, for example. Or maybe, here's even a better example. They've come to me and said, we want to have a list of all the baseball players, but we want to have that column that says bats, not say L, R, or B, or have nulls in it. We want it spelled out so that we can play with it. Okay, so let's do it. Let's do it that way. So what I could do here is, first of all, let's just do a backup. If I needed to make a backup copy of batting, what I could do is I could say select every record from batting. Okay, now, right now if I do that, my output's going to go to the screen. But right after the field list, right here, if I do an into statement, I can give it a table name. So I could call it something like batting backup. Just like that. And what's going to happen is every record, a mirror image of all the records we copy to batting backup. The only challenge that will happen is it makes a mirror image copy of the data, but it will not copy across any of what we call the constraints. It will copy the data types across, but it will not copy your primary keys. It will not copy any of your identities. But that's really not the normal purpose of this. The normal purpose is just to make a backup in case you screw up your original data, or to be able to give a subset. I don't have to just use these right here. I could just give them the columns that I want somebody to see or that I want backed up. But right now I'm going to do everything. So let's check it. We know that's right. Okay. Now I'm going to execute it. It says it copied the rows across, but I don't see it listed over here in my baseball table. And by the way, you will not be able to do this in my baseball table. For you to reproduce any of these, you're going to have to do it in your own database because you're writing data. You can't write to my databases. Now, the challenge here is it exists, it just hasn't been refreshed, which is too bad. So if I do a right click here and I do a refresh, there's my backup table right there. And you'll notice that when you look at the columns, that it has no primary keys in it as the original column had right up here. But it is a mirror image copy of the data that exists out there. So what I could do as well is I could come back in here and let's do name last, name first. I'm going to go ahead and I'm going to put a case statement in here, and let's clean this up a little bit so it's a little bit easier to look at. Now the into statement goes right at the end of the field list. So that means a case statement would go before it. So I'm going to do what we did before. I'm going to come back in here and create this case statement, and I'm going to say case when bats equals L. I should have just done an undo here, then left. Okay. When bats equal R, then right. When bats equal both, then we decided to switch before. And then we put an else in here and said else we just want it to say unknown. And I'm just going to use NK here. And then I end it. And at the very end of it, I give it a column header, and we call that, I could leave it as bats if I want to. Let's leave it at bats this time. Okay. Now, what I end up with is, and let's see, what am I missing here? Oh, my end statement. I got my end statement. Hold tight here. Let me see what I'm missing. So we'll take just a moment here. So I got my case when bats. What am I missing here? Select case here. Into. Oh! Let's go back in here and take a look, and I'm pulling it out of the wrong table here. And that should be bats here. There we go. Now, probably before I do the into statement, I would want to test it to make sure what appears down below is what I want to have into it, into the table. But right now, so let's just do that for a moment. Let me do a Control X here. Let's just run it. Okay, I've got the output. It looks right. I'm going to do my Control Z to put it back in again, and then let's re-execute this again. And I'm doing batting backup, so I better come back over here and first of all remove this table. Otherwise, I'm going to get an error telling me the table already exists. So I'm going to delete it. Right click on it. Very, very dangerous to delete a table because there's no undo. Get it back again. That's why we make backups. Now let's re-execute this. It says it worked. Let's refresh the table. And there's my backup. Now let's see what the table has in it. Let's select the top 1,000 rows. And now you're going to see this table is a mirror image copy of that select statement I did before, but now it's a physical table that sits out there. And let's take a look and see what it did for the bats column. How did it know what to do for the data type? Because it was derived. And notice that what it did is on its own, it realized that the largest piece of data in this column was 6 characters. So that's what it did, is it made it a varchar 6 characters for us. Okay. So that's pretty, that into statement, that spin-off table is really, really valuable. There is an advantage, though, that it's a snapshot of the moment that the table is run. But what we're going to find out here in a second is that that's not going to be good enough. Sometimes we're going to want to have a department have access to our data, but they're going to want to see what's called real-time data, which means I want to restrict what they see. I don't want them to see every column, but they want the data to be real-time, which means that as they run their statement, every time they run their statement, they're going to get it to run against the existing data that exists in my table. So what I want to do is introduce you to a view now, and views, again, this is probably one of the greatest modules right here that I'm covering, because views alone will do such amazing things for you. The first and foremost thing is to understand that a view is nothing more than a select statement that we save. You just go out and you write this big select statement and you say, save this as a view. And the moment that I save it as a view, that view will act just like a table. Well, with a couple of small exceptions, but right now, as far as we're concerned, it will act just like a table. So I could select from that view just like I would a table. Where that comes in with a great value is where the spin-off table is a snapshot of that data at the time it was originally run. The view runs every time that the person would run that view, they're going to get that data back. So I get some of the best things that I would get out of a spin-off table. I can write that view and only show specific columns. Same problem I had before. Maybe the marketing department wants to see some human resources data, but they want to see that data live. Okay, I don't want them to see everything, so what I can do is write a select statement that only shows them that the data that I want them or that they should see, and then I save that as a view and let them use that view. So let's take a look at the value of this view. First of all, I'm going to show you 2 different ways that we create a view. the first way I'm going to show you to create the view is how we would do it by hand. But you know, throughout this entire program, my goal is you have to know how to do it by hand, but your ultimate goal is to be able to do it quickly. So what I'm going to do is I'm going to introduce you to our second builder tool. The first builder tool we looked at is the structure of the database. The second builder tool I'm going to show you is going to be a query builder. Now, the query builder I'm going to show you, it's important for you to understand that you only use the query builder because it does it for you quickly, not because it does it for you because you don't know how to do it. Because keep in mind, you're going to have to come back in later and maintain these statements that are being built. And if the computer does it for you, you can't maintain it. So, how do you do a view? Well, the first thing, all you have to do is you write your select statement out that shows the data that you want in the view. So in this case, what I want to do is I have this select statement here that only has Washington customers in it. And what I want to do is I want to create a view once that's created called VW Washington customers. So that later, all I have to do is do a select from VW Washington customers, and that's all I'm going to get is my Washington customers. I don't have to go back out there every time and rewrite this select statement right here. I know that that select statement basically is this guy right here. Now, another really powerful reason we do this is because if you remember back here, let's look at what I had before on that alias. Remember, I told you how complicated this statement is, and you certainly don't want to type that statement in over and over and over again every time you want to use that statement. So what you're going to do is you're going to write this complicated statement out, and then you're going to save it as a simple view. And the moment you save that simple view, you'll be able to use that view just like this table. And we're going to take a look at that here. You'll see the advantage of that in just a second here. So the very first thing I want to do is let's go back over. We've got this statement right here, and this was automatically generated. Let's look at this guy right here. So right now what I did is I created that into a spin-off table. Let's take this out. I want to get rid of that, and let's assume that the people that want to have this select statement don't want a spin-off table. They don't want to look at data the way it was. They want to look at data the way it is. So every time they run a statement, they want to see the current names, and they want to know the current interpretation of left, right, or switch. This methodology won't work. Now, before I go on, though, I should point out that by giving them this backup database here, I can also let them play with this data. They can manipulate it. They can do whatever they want. They can add columns to it. But by me giving them a view, I'm not going to let them do that. The view is going to be just what they get. So I'm going to take this statement out right here entirely. And I'm also going to come back over here and I'm going to get rid of this batting spin-off table that I did. So I'm just going to delete it out just like this. Okay. Now, again, I'm going to run this statement to make sure that it works. It says it works. So at the very top of this statement, I'm going to come back up here. I'm going to type in create view, and I'm going to give it a name. Now, what I typically do, my technique is I always start my views out with VW. Now, why would I do that? Because later in my code, I want to know, was my select statement that I created based on a view, or was it based on a table? And the VW in front of that will let me know. So in this case, what do I got here? I'm going to call mine VW type hitters. Right here. And then I put a keyword as at the end of it. So what I'm basically telling it is I'm saying create a new view. I want to call it VW type hitters, and I want it to be this select statement right here. Okay? So the first thing I'm going to do is check it to make sure it's okay. Just like that. It says it's okay. So let's run it and see what happens. Whoa, wait a minute. Nothing happened. Why did nothing happen? Nothing happened, folks, because we just created the view. We haven't used it yet. All we said, this command just said take the select statement and create that view. And now if I come over to my views here, in the past we've been looking at tables, but now if I look at my views, and you'll see that there's some views that were created in the past for us, and I refresh it, I should find VW type hitters right there. VW type hitters. Now, what I'm going to do is open up a new query window. Okay, I'm going to copy that because I'm lazy. I'm going to open up a new query window here, brand new one. I'm still in baseball, and now watch what I can do. I can say select all records from VW type hitters. Just like it's a table. And watch this. And I'm getting the same data back. Now, what it does, and the way this works is, and I like to think of it simply, it's just running that select statement for me and pulling all records out. That's all it does. Is it's running a select statement that was based on this view, and it's pulling all records out. But it even goes better than that. Once I've got this view now, I can change the order. I can tell it what columns to look at. So let's say all I want to do is look at the last name and bats. Okay, I can do that. Name last, bats. And see how it turned out? It's interesting, though, that it sees it as an error up here. I'm not sure why it does that as a view when it doesn't do it as a table, but obviously it's working just fine. Now, I should also mention, if we went back here to where this was created, whatever, when I create this view, whatever the column headers are that exist in this view, okay, will be the column headers that the select statement returns back. So notice that when I ran that, okay, it brought back bats with the uppercase B, because that's how it was originally created. But it works just like a table. So later, when we create these complicated joins, we're going to take that complicated join and we're going to come back here and we're going to create it as a view. And from that point forward, we just use the view and we end up getting the same thing that join gives back to us. So hold tight, because it's going to make a lot more sense later. But I want to show you something else that I can do here. So a moment ago, I showed you how to create the view in the code. You simply add that statement at the top, it creates the view, and once you do it, it's done, it's created. But I also want to show you one other thing, and in the process of showing this to you, I'm going to show you two things at once, two different builders. So if I come down to this view right here, okay, and I do a right click, and I say I want to create a new view, check this out. This is pretty slick. It creates what's called a query builder. It lets me build that view. Okay, so in this particular case, what I'm going to do, and we'll do this later, folks, is I'm going to create a join. And I'm going to make this join complicated, but we're going to play around with this a little bit later, so don't worry about understanding the join right now. I just want to show you how I can make a complicated join work. It could be a very simple select statement here. I'm going to show you more in a minute, so hold tight. So what I'd like to do is I just want to have payroll data up here. So payroll data, so I take the players table, I say I want all the players, and then I want their salary data to also show. So notice what I'm doing is I'm double clicking, or I could click on one of these and select add. So I click those two column tables and they're added to this viewer here. Okay. Now I'm going to close this out because those are the only two tables I need. Now notice that down below here I've got different builder options. I can actually type in here and have it fill this in. So this is completely, all three of these are separate areas that do very much the similar thing. But the first thing I'm going to do here is I want to join my table. Now later we'll find out how this works, but I'm going to take this player ID here and I'm going to join it to this player down here. So I'm simply going to grab it and drag it over to player ID and let up on it, and it created a join. And notice it's building my select statement for me down below here. Later we're going to understand exactly what it's doing. Now the next thing that I want to do is decide what columns do I want to show up. So I want to get salaries of players. So what I'm going to do right now is I want to say I want to have the person's last name, I want to have their first name. And notice how it's putting the table name in front of it plus this DBO. We talked about that before, where I could use, if I wanted to, an alias here. I'm not going to do that right now. I could if I wanted to. Okay. Now, the next thing that I want is I want the player, let's see. Then I want to know the year that they played here. I want to know the team that they played on, and I want to know how much money that they made. Now, this is a typical select statement that's a join. And notice what it's done down here is it's built the statement entirely for me. In fact, watch this. I'm going to grab that statement right here. I'm going to copy it. Let's come back here and let's paste it in and let's watch it run. And look how cool this is. It tells me every player for every year they played and what their salaries are. Okay, but that statement is a is a pain to have to look at. I certainly don't want to type that in every time. I'd really like the computer to do some of the work for me. So what I could do here is, once I created this, if I'd done it by hand, I could put that create view in front of it. But let's go back to what we've been doing so far. We've been letting this builder build it for us right here. Now, if I wanted to, folks, I could come back in here and I could modify the statement down here if I wanted. I could say, you know what I'd really like to do is, rather than call this column name first, maybe I want to call it first. Now watch what happens. Okay, I'm giving it an alias just like we've always done. I'm going to click out of it and notice immediately it came back in and added an alias here for me. Or I could have come back in here and added the alias, depending on how you want to use this. Now watch what happens when I click out of it. It added last here. And notice it modified my code to put the as in. But it doesn't have to be there. It just chose to put it in there on the as statement. If I put it, it's pretty good about it too. If I want to do last name, check this out. If I do last name and I put let's try this. If I put a space in between it and click out of it, it knows that it's last name with a space, and rather than putting the apostrophes in, it uses that other method with square brackets. But I don't want to do that. I just want to call it last. Let's change it here. Now, the cool thing about it is, because I started it as a view, okay, when I'm done designing it, however I choose to do it, and I do a save up here, okay, I will hit save, okay, it comes back and says, what do you want to call your view? Okay, and I'm going to call mine view, and I think I already have, do I have a salaries over here? Yes, I do. I already have player salaries. So my technique on a join is to say, to show the join between it. So I would say players and then salaries, just like this. I've already got the same table created over here. We're going to take a look at it. But then I click OK and it would save it. And then once it saved it, I simply close out of it here. And it would be done. Now I could close out of it here, just like when we were modifying tables. Same thing holds true though. If there's a mistake in here and I close out like this without saving and it finds the error, it will tell me there's an error, but it throws me out of it. So I always suggest you reach up here and you use this save button to save your view as you're going along. So let's close this out here. And now, just to prove that this is working, let's get rid of this guy. And now I'm going to do a select all fields from VW players salaries. Is that it? Players salaries. And watch this. Oops. Let's try VW. Okay. And now I have my view created, and I've got the team that they played on, I've got the salary, and I could do all kinds of cool stuff with this particular view. So now with this view I could say I want to know all the salaries from where team ID is equal to Seattle, SEA. Okay. And I'll get all the salaries for the Seattle, and if I want to know a particular year, I can say and year ID is equal to 2010, and I'm only going to get, so it acts just like a table once we create this view, but it's so much easier to use this than that complicated select statement that we had before. Plus it allows me to hide columns, so I could give this view access to this view to somebody else, and they'll never see the other columns that existed. So I can protect that as well. Let me even go a step further here, as long as I've got it. What if I want to know what the salary were for the Seattle team in 2010? What was the total salary? Check this out. I could do sum, and in this case the column is salary, so I'm just going to treat it just like it's a regular table. Salary. And I'm going to call it total salary. Oh, and this is so cool. Check this out. It tells me that this total salary, and I better copy that because I can't read that very well. We'll paste it up here so I can read it. So the total salary for the Seattle Mariners in the year 2010 was $86,510,000. Pretty cool, and that all came from that view, and I could look at a single team using that methodology. So So let's jump out. So again, we want to take that complicated view and make that into a simple, a complicated join and make it into a simple view. But I want to show you one other thing as long as I've got you here. And we've already done, we can take a look at, we've done the into statement table already. So we've already viewed that one. We've looked at the views already. What I want to do before I break away here is show you one other thing, and this is probably one of those things that you're going to come back and say, gee, Tom, why didn't you show me this in the very beginning? And the reason I didn't show you this in the beginning, and I'm a big believer in this, is that you want to use the builders whenever you can, but you don't want the builder to do the work for you because it does the work for you. You want it to do the work for you because it does it fast. And the reason is later, you're going to be writing programs that generate this. You will have to write programs that create views, and you're going to have to know how to do all of this by hand, even though here within Management Studio, we can use some cool builders. So watch this. I'm in baseball. I've got an empty query screen here. I'm going to do a right click. And I'm going to come down and I'm going to tell it that I want to design a query in the editor. Oh my God, this is what I was talking about. Check this out. I can let my select statements that you've been generating so far can be generated by a builder. So let's just do something simple. I'm going to do players. This is very similar to that view builder we just looked at, except it doesn't create a view, it creates a select by itself. I close this out now, and now I can come in and say, you know what, I would like to have the last name. The first name, then the last name. I might want to have their weight and their height, and I want to have bats in here. Okay. Now look what it's doing down below, folks. It's generating my select statement for me. Okay, and I can go ahead and click OK, and look what it did. Is it built it for me, and I can run it. And there is my select statement. But even better than that, check this out. If I highlight that select statement and I do the same thing again, go to the, it will take what I've already got and let me continue with it. Okay, so it already sees those columns that were selected in here. And now let me increase the size of this because there's other stuff that I can do in here. I can come back in here and there's a lot of stuff that I wouldn't do because I think there's easier ways to do it outside. But if I want to sort here, then what I do is I identify the sort that I want. I tell it, I can simply click in here and say I want it to sort by height descending. And notice that as soon as I click out of it, it's the sort order is descending here, but it tells me the sort order here is a number 1. Now you would think that it would use that technique I showed you earlier, the order by column 1, but it doesn't. Fortunately for us, it actually puts in the actual column name and for us the descending. And I can click OK, and it's modified it. I could rerun it, and now it's sorted descending. Could highlight it again, come back in here. I could design the query in the editor again, and let's say that I want to do an alias. I want that to be, instead of name first, I just want it to be first. And I want it to be last down here. Then I can do that. Now, one thing I will point out, though, is this guy does do a good job with basic select statements and basic joins. And it will work when you start using things like case statements, but it doesn't do a really good job with case statements trying to analyze what it is. So that's where you're going to want to go back in and probably do your coding by hand. But I will guarantee you that I use this often. I mean, I'm going to use this builder as much as I can because it does so much work for me, whether it's the view builder or whether I'm just simply doing a right click down here and I'm telling it that I want to design a query in the editor because it does it fast. Especially when I'm doing a join statement. Why would I go back out there and have to type all these statements out in fear of making a typo, which you've seen, when I know I can use the builder and it's going to build it for me? At least, even if I know I'm going to do a more complicated one, it's going to have a case statement in, build the basic structure without the case first, then go back in and apply the case. But why would I spend an hour doing something like that, charging my client, when I can do it in 5 minutes? Not only do I owe it to myself, but I owe it to my client to only charge them 5 minutes rather than the 1 hour just because I can type it out by hand. So hopefully this made sense, folks. We'll continue with the next topic shortly.